Welcome to this comprehensive guide for beginner Unity developers, focusing on profiling and performance optimization to create smooth and engaging game experiences. In this video, we will explore essential techniques and tools to help you build high-quality, performant Unity projects from the ground up. Understanding how to identify and address performance bottlenecks is absolutely essential for any developer aiming to build high-quality Unity projects. This knowledge is crucial for delivering a polished and enjoyable user experience, preventing frustration caused by lag or stuttering. Performance bottlenecks are critical issues that significantly slow down your game, leading to frustrating lag, noticeable stuttering, or unacceptably low frame rates. These problems can severely impact player engagement and overall satisfaction with your game. These critical bottlenecks can originate from various sources, including inefficient code that performs unnecessary operations, an excessive number of draw calls taxing the GPU, memory leaks that consume system resources over time, or unoptimized assets such as high-resolution textures or complex 3D models within your project. Identifying these specific bottlenecks is always the crucial first step towards effectively optimizing your game's performance. Without precise identification, optimization efforts can be misdirected and yield minimal improvements, making this diagnostic phase paramount. The Unity Profiler is an indispensable built-in tool that provides real-time performance data directly from your Unity project. It acts as a window into the inner workings of your game, revealing exactly where resources are being consumed. This powerful tool allows developers to meticulously monitor CPU usage, memory allocation, rendering performance, audio performance, and many other critical metrics. By observing these metrics, you can gain a deep understanding of your game's resource consumption and identify areas for improvement. To access the Unity Profiler, simply navigate to Window, Analysis, Profiler within the Unity editor. This straightforward path will open the Profiler window, ready for you to begin your performance analysis. The Profiler window is thoughtfully divided into several modules, each designed to display performance data related to a specific area of your game. This modular design helps in organizing and understanding the vast amount of performance information available. Key modules you'll frequently use include CPU usage, memory, rendering, audio, and physics, each offering unique insights into different aspects of your game's performance. Understanding what each module represents is key to effective profiling. The CPU usage module reveals how much time your CPU dedicates to various tasks, such as rendering, scripting, and physics calculations. It provides a detailed breakdown of where your CPU cycles are being spent, allowing you to pinpoint performance-heavy operations. This module is invaluable for pinpointing inefficient code or algorithms that are consuming excessive CPU resources and slowing down your application. By analyzing the call stack and execution times, you can identify specific functions or scripts that need optimization. The memory module meticulously tracks both memory allocation and garbage collection events within your project. It shows how much memory your game is using, what types of assets are consuming it, and when garbage collection occurs. It helps identify memory leaks or excessive memory usage, which can lead to crashes or significant performance degradation over time. Understanding memory patterns is crucial for maintaining a stable and performant game, especially on devices with limited RAM. The rendering module provides crucial insights into your game's rendering performance, including draw calls, batches, and shader performance. It helps you understand how efficiently your game is being drawn to the screen. This helps identify bottlenecks related to rendering complex scenes or using unoptimized shaders that strain your GPU. High draw call counts or complex shaders can significantly reduce frame rates, making this module essential for visual optimization. The audio module monitors audio performance, including CPU usage and memory allocation specifically for audio assets. It helps ensure that your game's soundscape is not inadvertently causing performance issues. It helps identify issues related to playing too many audio sources simultaneously or using unoptimized audio formats that consume too many resources. For example, uncompressed audio files can quickly deplete memory, while too many active sound effects can burden the CPU. The physics module tracks physics performance, including CPU usage for physics calculations and the number of active physics objects. This is particularly important for games with complex interactions and simulations. This module helps identify performance issues stemming from complex physics simulations or an excessive number of collision checks. For instance, having many rigid bodies interacting or complex mesh colliders can quickly become a performance drain. To profile your game directly in the Unity editor, simply press the play button and observe the profiler window. As your game runs, the profiler will begin collecting and displaying real-time performance data. The profiler will collect performance data in real time, allowing you to instantly identify performance spikes or bottlenecks as they occur during gameplay. This immediate feedback is invaluable for debugging and optimizing your project. For more accurate testing, you can profile the game on a target device by connecting it to your computer via USB and selecting it in the profiler window. This is crucial for understanding how your game performs on actual hardware, such as a mobile phone or console. This crucial step allows developers to test the game's performance on the actual hardware it will be running on, providing real-world data. Performance can vary significantly between the editor and a target device, making device profiling indispensable. Enabling deep profiling provides even more detailed information about script execution, breaking down individual function calls. This level of granularity can help you pinpoint the exact lines of code causing performance issues. However, be aware that deep profiling can impact performance itself, so it should be used judiciously and only when necessary. Its overhead can sometimes obscure the true performance characteristics of your game, so use it for targeted analysis. The Profiler Analyzer tool is excellent for comparing two profiling datasets, helping you analyze how changes affect your application's performance. This allows you to track improvements or regressions over time, ensuring your optimizations are effective. Beyond Unity's built-in tools, the Visual Studio Profiler is a powerful asset for analyzing the performance of C# code within your Unity projects. It offers a different perspective, focusing specifically on your script's execution. It offers advanced debugging features, including setting breakpoints, evaluating expressions, and inspecting variables with precision. These capabilities are essential for understanding the flow and state of your C# code during runtime. First, ensure that Visual Studio tools for Unity are correctly installed. Unity 2020.1 and newer require a specific Unity package for external editor tools. This integration is vital for seamless debugging and profiling between Unity and Visual Studio. Next, in Visual Studio, attach the debugger to the Unity process, which allows you to step through your code and identify bottlenecks. This connection enables you to pause execution, examine variables, and trace the path of your program. Once attached, use the Visual Studio Profiler to analyze CPU usage, memory allocation, and other performance metrics of your C# code. This provides a granular view of your script's performance, complementing the Unity Profiler's broader overview. Now, let's dive into some beginner-friendly optimization tips and tricks that you can apply to your Unity projects. These practical strategies will help you improve your game's performance without requiring advanced expertise. Optimizing your scripts is fundamental. Always strive to avoid redundant calculations and utilize efficient data structures. For example, using a dictionary instead of a list for frequent lookups can drastically improve performance. Minimize memory allocation wherever possible and use coroutines wisely to manage asynchronous operations without blocking the main thread. Excessive new object creation can lead to frequent garbage collection, causing performance spikes. Optimizing your assets is equally important. Compress textures to reduce their memory footprint. This can significantly lower the amount of RAM your game consumes, especially on platforms with limited memory. Consider using lower resolution textures for objects that are far away or less critical, and optimize 3D models with level of detail, or LOD. LOD allows you to swap out high-detail models for simpler ones as they move further from the camera, saving rendering resources. Also, ensure your animations are optimized to reduce unnecessary bone calculations and keyframes. Complex animation rigs with many bones or excessive keyframes can be computationally expensive, so simplify where possible. Reducing draw calls is crucial for rendering performance. Use static batching for non-moving objects to combine them into fewer batches. This tells the GPU to render multiple objects in a single pass, reducing overhead. Similarly, Employ dynamic batching for moving objects when applicable, and combine meshes where possible to further reduce draw calls. Dynamic batching works for smaller, moving objects, while combining meshes is effective for static, complex structures. Utilize texture atlases to pack multiple smaller textures into one larger texture, minimizing texture swaps and improving rendering efficiency. This reduces the number of times the GPU has to bind new textures, speeding up rendering. Optimizing lighting can significantly impact performance. Use light mapping to bake static lighting for stationary objects. Baked lighting is pre-calculated and stored in textures, making it much less computationally intensive than real-time lighting. Reduce the number of real-time lights in your scene and disable unnecessary shadows, as they are computationally expensive. Real-time lights and shadows require complex calculations every frame, so use them sparingly. For physics, use simple colliders whenever possible instead of complex mesh colliders. Primitive colliders like spheres, boxes, and capsules are much more efficient for physics calculations than detailed mesh colliders. Reduce the number of collision checks and disable physics on objects that do not require it to save valuable CPU cycles. For example, static background elements don't need active physics, and reducing the frequency of collision checks can also help. Actively work to reduce the impact of garbage collection by minimizing temporary object allocations. Reusing objects from a pool instead of creating and destroying them frequently is a common and effective strategy. Finally, always give players the option to change quality settings at runtime, providing them control over the game's performance on their specific hardware. This empowers players to tailor the experience to their system's capabilities, ensuring broader accessibility. Consider platform-specific optimizations for different target environments. What works best for a high-end PC might not be suitable for a mobile device, and vice versa, so tailoring your approach is key. For mobile devices, prioritize reducing texture sizes, simplifying shaders, and minimizing draw calls to ensure smooth gameplay. Mobile hardware has more limited resources, so efficiency is paramount for a good user experience. When optimizing for PC, you can leverage higher resolution textures, more complex shaders, and more detailed models due to greater hardware capabilities. PCs generally offer more processing power and memory, allowing for richer visual fidelity. For console platforms, optimize by utilizing platform-specific APIs and tools to extract the best possible performance from the hardware. Each console has its unique architecture and optimization strategies, so understanding these is crucial. By applying these profiling techniques and optimization tips, you'll be well-equipped to create high-performing and enjoyable Unity games. Consistent application of these principles will lead to a more polished and professional final product. Keep practicing these methods, and your Unity projects will undoubtedly stand out with their exceptional performance. Continuous learning and application of these optimization strategies are key to becoming a proficient Unity developer.